Welcome to lecture series on EPG Padasala for Computer Science. Today's lecture class we will be discussing software configuration management. Learning objectives: outline the need for software configuration management, address the concept of software baselines, identify and organize configuration items to be controlled with software configuration management, to understand why software configuration management is of crucial importance in medium to large scale software development projects. Configuration management: a system can be defined as a collection of components organized to accomplish a specific function or set of functions. The configuration of a system is the function and or physical characteristics of hardware, firmware, software or a combination thereof as set forth in technical documentation and achieved in a product. Configuration management is the discipline of identifying the configuration of a system at distinct points in time for systematically controlling changes to the configuration and maintaining the integrity and traceability of the configuration throughout the system development life cycle. Software configuration management: the set of activities that have been developed to manage change throughout the software life cycle. The objective is to systematically control changes to the configuration and maintain the integrity and traceability of the configuration throughout the system's life cycle. We are aware that when we talk about a system that is operational, lot of building blocks are involved: hardware, operating system, the communication network with interconnecting devices like hubs, repeaters, bridges, routers, gateways. To the system to be functional, each building block or component must function appropriately. To state in other words, each building block is expected to carry out the function it is supposed to. Coming to the software development life cycle, we are aware that the umbrella activities involved during the development phase include analysis, design, code and test. Once the software has been tested and deployed, the software enters into the maintenance phase. We are aware that changing requirements have to be addressed in each phase of the software development life cycle and in the maintenance phase too. We are aware that in the maintenance phase, business process re-engineering activities will also be carried out. Irrespective of which phase we are in, there will be changing requirements. Depending upon the phase we are in, the cost will also have to be estimated for each changing requirements. If we are in the analysis phase, prior to completing the software requirement specification document, the changes, if any, can be addressed easily. In case system analysis complete, the deliverable SRS is also signed by the client and the developer, and we have entered into the design phase. When there is a change, we have to go back to our requirements analysis phase, make the changes and then re-enter into the design phase. The degree to which the changes will affect the artifacts that are developed has to be carefully addressed. We are aware that design can be architectural design and detailed design. We follow a divide and conquer principle as discussed earlier. Modules are identified, the relationships between the modules are also identified in architectural design. When there is a change in functional requirements in your architectural design, you may have to modify the modules, the relationship among the modules, in addition to modification in your software requirement specification document. You have completed the architectural design, the design has been approved, you are in detailed design. Now when there is a change, your requirement specification document has to be modified, your architectural design has to be modified. In case detailed design is complete and then there is a change in requirement, the changing requirement has to be incorporated in software requirement specification document, architectural design and detailed design. You are in coding phase. We are aware that sometimes modules are developed concurrently by different developers. There is a changing requirement which requires modification in all previous stages and the modules too. Coding is complete, you are in the testing phase. If there is a changing requirement, all the previous phases, the corresponding change has to be done, and if necessary you may have to test the entire software or part of the software. Regression testing is one testing that is commonly used when a completely tested software is modified to incorporate changing requirements. Once testing is complete and the product is a quality assured software product, the product is deployed and the product enters the maintenance phase. During maintenance phase, as I have stated, business process re-engineering activities will be carried out, changing requirements will be addressed. As you move from one phase to another, and if you want to address changing requirements, the cost increases. Similarly, when you are in coding phase, there is a change in requirement. When you address the changing requirement, not only the cost gets affected, the schedule also gets affected. Incorporating changing requirements sometimes may cause a schedule slippage. A set of management disciplines within a software engineering process to develop a baseline. Software configuration management encompasses the disciplines and techniques of initiating, evaluating and controlling change to software products during and after a software project. Configuration item, a piece of software or work product which is subject to change. Change request, a formal report that contains the request for modification in a configuration item. Versions and configurations. A version identifies the state of a particular configuration item or a configuration at a well defined point in time. Promotion, a promotion is a version of a configuration item or configuration management aggregate that has been available to other developers in a project. Release, a release is a version that has been available to the user or the client. Repository, it stores the various releases of a configuration management item or aggregate. Workspace, it is a library of promotions. Configuration item identification, modeling the system as a set of evolving components. Promotion management, the creation of versions for other developers. Release management, the creation of versions for clients and users. To be consistent with the requirements, often developers use prototypes. A prototype is a working model of the system. A prototype can be a throwaway prototype or evolutionary prototype. In a throwaway prototype, the functional requirements are implemented, demonstrated to the client, and then it is discarded. In an evolutionary prototype, the requirements are implemented as increments, demonstrated to the client, and refined further and further until it serves as the end product. The major advantage of prototyping is the development is evolutionary, and since the developers interact continuously with the client, any deviation from the functional requirement will be identified in the early stage and it can be corrected. Change management, the handling, approval and tracking of change requests. Branch management, the management of concurrent development. We are aware that in most cases modules are developed simultaneously. Why simultaneous development? Delivery is fast. In addition to that, from the technical point of view, each module performs a well defined task. Module has a input, process and output. The output of a module can be an input to another module. Modules can be individually tested. Modules can be reused. So, modules can be developed simultaneously and tested also simultaneously. When I mean tested simultaneously, unit testing on each module can be performed. Of course, after unit testing is complete, modules can be integrated and tested. We have discussed different integration testing techniques like top down integration, bottom up integration, sandwich integration and big bang integration. And we have stressed that big bang integration is not a practical approach. Variant management, the management of coexisting versions. Software configuration management tasks, identification, tracking multiple versions to enable efficient changes. Version control, control changes before and after release to customer. When I mean before, control changes when the software is being developed. Control changes during your analysis phase, control changes during your design phase, control changes during your coding phase, control changes during your testing phase. Once the product is deployed, control changes when the product is in maintenance phase. Change control, authority to approve and prioritize changes. Configuration auditing, ensure changes are made properly. Reporting, tell others about the changes made. Which of the entities should be configuration items? Problem statement, software project management plan, requirements analysis document, system design document, project agreement, object design document, dynamic model, object model, functional model, unit tests, integration test strategy source code, API specification, input data and databases, test plan, test data, support software part of the product, support software not part of the product, user manual, administrator manual. Even though I am going to shortlist a few among these stated in the next slide, it depends upon the organization. However, there are certain entities which has to be configuration items. To give you more clarity, when you look into the software development life cycle from a practical point of view, not all companies maintain the entities stated here as an document. Simple example, the software requirement specification document will be prepared, since it is the legal contract between the client and the developer. A class diagram or an entity relationship diagram will be modeled, and the same will be mapped into a database design. Sometimes a DFD data flow diagram will be modeled and mapped into architectural design. Other diagrams that need to be modeled include use case diagrams, sequence diagrams, interaction diagrams, state transition diagrams, deployment diagrams. Whether all these diagrams are modeled and documented is a question mark. Sometimes the analysis team, design team may feel not all models are required. It is sufficient we model an entity relationship diagram, a data flow diagram, map the entity relationship diagram to a relational database design, map the data flow diagram to architectural design, model a state transition diagram to draw inference for which input there will be a change in state, model a use case diagram so that the scenarios are clear. And in most cases, we do not model all diagrams as specified. Second point, when there is a changing requirement, strictly speaking, you have to modify the software requirement specification document, and all models or diagrams which will have an impact of the change. Then you have to modify the code. Due to time pressures, cost factors, sometimes the SRS will be modified and directly programmers modify the code, which is a wrong practice. When there is a change in requirement, the requirement change may be in the application program level or sometimes in the database level. Simple example, calculating income tax. The functional requirements depends upon the government policy every year, and every year there is a need to modify the application program. If there is change only in the application program level, your data design or database design will not get altered. So you need not modify your entity relationship diagram or your table design. However, there is a need to modify your software requirement specification document and then your application program. So a thorough analysis of the change and the impact of the change has to be done, and accordingly your SRS and related diagrams or models need to be modified. And as I have mentioned, in the next slide we will be looking into the entities that should be configuration items. However, depending upon the organization, there can be additions too. For example, I said when there is a changing requirement incorporated in the program, regression testing has to be carried out. However, if the organization feels it is going to test the entire software, it can do it. Possible selection of configuration items: requirement analysis document, system design document. As I have mentioned, when there is a change in functional requirements, not always your design need to be changed. Your module structure remains to be the same. The process logic what you have implemented in a module, which is part of your detailed design, may have to be altered. Object design document, unit tests, source code, input data and databases, test data, support software which is part of the product, or possible selection of configuration items. Configuration management standards. Configuration management should always be based on a set of standards which are applied within an organization. Should define how items are identified, changes are controlled, versions are managed. Should be based on an evolutionary process model rather than something like the waterfall life cycle model. Baselines, which is one important concept in software configuration management. A specification or product that has been formally reviewed and agreed to by responsible management, that thereafter serves as the basis for further development and can be changed only through formal change control procedures. As a simple example, consider architectural design. Architectural design is complete. Once the architectural design is complete, in practice the design will be presented to a team of architects who are expertise in the area of system design. They brainstorm themselves, give their valuable feedback, if necessary make changes to the design, and finally the design is approved. That is what I have stated, a specification or product that can be formally reviewed and agreed to by responsible management, that thereafter serves as a basis for further development and can be changed only through formal change control procedures. Examples: baseline A, the API has been completely been defined. The bodies of the methods are empty. Baseline B, all data access methods are implemented and tested. Baseline C, the GUI is implemented. Naming schemes for baselines, many naming schemes for baselines exist, 1, 2, 3, etc. In general, a 3-digit scheme is quite common. When there is a major external release to customer, you may number it as 1, 2, 3 and so on. When there is a minor internal release by the developer, 1.2, 1.3. When there is a small revision by the developer, 1.2.1 and so on. Types of baselines: as systems are developed, a series of baselines is developed, usually after a review: analysis review, design review, code review, system testing, client acceptance. developmental baselines, functional baseline, product baseline. Transition between baselines, baseline B, functional first prototype, baseline C, product beta test. Next baseline is release. How do we manage changes in baselines? We have change management procedures, the available time too. Change management software systems are subject to continuous change requests from users, from developers, from market forces. Configuration management cycle, customer generates a change request. Project manager assigns change request to development team. Development team checks out necessary configuration objects, completes necessary changes, approves changes. Next, development team checks in modified configuration objects and notifies configuration manager. Configuration manager creates new system baseline, prepares new system release for operation if necessary. The change management process requests change by completing a change request form. Analyze change request. If change is valid, then assess how change might be implemented. Assess change cost. Submit request to change control board, else reject change request. If change is accepted by change control board, then repeat, make changes to software, submit change software for quality approval until software quality is adequate. Create new system version. If the change is not accepted, reject the change request. We have a change request form in which the changes required are recorded, why the change is required, and the urgency of change is also mentioned. It also records change evaluation, impact analysis, change cost, and recommendation. Cost is one factor that plays a major role here. When there is a change, when you are in the testing phase, the cost involved will be high. Change control board, changes should be reviewed by an external group who decide whether or not they are cost effective from a strategic and organizational viewpoint rather than a technical viewpoint. Should be independent of project responsible for system. The group is sometimes called a change control board. It includes representatives from client and contractor staff. We have already discussed the fundamental sources of change: new business or market conditions, new customer needs, business reorganization, budgetary or scheduling constraints. And I have stated change request specifies the procedures for requesting a change to a baseline configuration item and the information to be documented. Summary: configuration management is very crucial for evolving software systems. Careful planning is required, considering aspects like the components that are likely to be changed, any other subsystems that may have to be changed for the modification of the given system, analysis of cost, etc. Configuration management makes sure that these changes do not cause undesired impact, ripple effects on the other subsystems. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.